Okay, this is lesson 23, and it is the last lesson that we're going to do. I've titled it NAND Gate Circuits. So what we learned in the last lesson was how to use the circuit board, and there were logic switches and logic indicators and how they kind of worked. And so what we're going to look at now is some NAND gates, and then how we're going to use that with the circuit board. So what you have, or when it arrives, you will have, it's called a quad NAND gate, integrated circuit chip. And it's called 74LS00. This has to do with, there's a family of chips called 7400, and the LS means certain things, and there's lots of different numbers, but the one we're going to use is the 74LS00. So the first thing on page 187, you'll need to draw this. So I've got it drawn up here, and I want to explain how this works, and then we'll see kind of what we do with this. So I have one that I will show you here. You can just kind of see. It looks like the ones that we did before, but it has 7 legs on each side, or pins, instead of 4 on each side. Okay, so the way this thing works, there are actually 2 dots on it, but the best thing to look for is this little notch here, and I would say it goes to the top. On the top of it there's some writing and the number, and you should be able to read it looking from the left. So when you put it in the circuit board, you'll put it in oriented this way. And then you have to keep track of the pin numbers. So it starts at the top left with 1, goes down and around and up to 14 on the other side. Just like the other one went from 1 to 4 and then 7 to 8. Now, pin 7 always goes to ground. So that's just always goes to ground. Pin 14 up here goes to a power source, and we're going to be using the positive 5 volt fixed voltage, which is the red terminal. Then you can see the diagram for a NAND gate. We have 2 inputs and an output. So 1 and 2 are in, 3 is out, 4 and 5 are in, 6 is out. Then you have to watch when you go over here, because the logical thing would be to say 7 and 8 are in and 10, or 8 and 9 are in and 10's out. That's not right. It's the other way around. So 9 and 10 are in, 8 is out, 12 and 13 are in, and 11 is out. Now, several things that can be done. You can use one NAND gate, and what I'm going to show you in a little bit is using just one NAND gate. But then you can use the output of one NAND gate as the input to something else. And I'll go ahead and tell you now, the general plan is that you're going to do the 1 and make sure you understand how that works. And then if you remember in lesson 21, we went through and showed how you could use NAND gates to make all of the other gates. So I'm going to have you making the connections using those diagrams to make the gates for the OR and all those others, and to verify the truth table. Now, so that I can be sure that you're actually doing this and doing it correctly, I'm going to have diagrams for you to show how you make the connections. So over here, this is kind of the basic layout of the pages. This represents this whole thing here, and I've copied one of the things that I got off of the internet, a diagram that I got from the internet, and I've put 4 of them on a page, and I've left space up here for you to actually draw the gate. So for instance, the first one that you'll do, I think, is a NOT gate. So I will probably have those labeled up here. And then you would draw the NOT gate here, and then here you would show the connections. And I'll show you in just a minute what I mean. So you'll show where the switches go, if it's one switch or two switches, and then the output. If there's only one gate, then you'll just use the one. If you use more than one gate, which the rest of them do, then you'll have to show the output of one of them going over to the input of another one. So back over here, what we're going to end up doing in the very first thing, and this follows a lot of what he has in the book, in the sections that I've got for the reading, so you can read there if you want to. But it seems that if you're only going to use one gate, that you have to ground the input of the others. And I have this listed in the instructions. So if you're going to use the first gate, that uses pins 1, 2, and 3, then you need to ground the input for this gate, which is 4 and 5, this one, which is 9 and 10, this one, which is 12 and 13. And then you will be going from the switches. The switches, remember, were in the lower left-hand corner. Those are the inputs. And then 3 is going to go to an output, and an output goes to the logic indicators. So the best thing to do when you use this chip is to put it kind of in the middle of the circuit board, because you're going to have wires from the switches to here, and then from here to the logic indicators. And you're going to need a number of wires, so you may have to actually end up cutting a few more. You're going to need several longer ones, and then you're going to need a bunch of shorter ones. Okay, so on this one, I want to show you what I mean. Okay, when you use the first gate, the first NAND gate, and in there it's going to tell you to verify the NAND gate truth table. So remember that we have, these will be connected to switches. So I'm going to draw with red. I'm going to draw over here. This is going to be switch 1. And I'll show you this in a minute there. So this is going to be to switch 2. So those are the inputs. Then this is the output, and it's going to be to logic indicator 1. Okay? And then remember that on the switches, low, kind of the lower position is low, or corresponds to 0. The higher position corresponds to 1. So with a NAND gate, and you should probably look back at the truth table for the NAND gate. If you have a 0 and a 0, then the AND would give you a 0, but the NOT here gives you a 1. So 1 is a high, and so if you have these two in the two low positions, then this should give you the red LED lighting up. Okay? Now, if you're going to have the output of this one as the input of something else, and there's one of these gates, I don't remember which it is, but I'll just show you the general example. If you have the output of this as the input of something else, then on your diagram, you'll just draw a line. And so on here, when you're drawing these, you should draw your lines here to show what goes to switch 1 or switch 2, or to which indicator. And I believe we only really need to use one of the indicators, because in all of these things we end up with just one output, but we have several different inputs. However, you only have these two, at least to begin with, you only have these two inputs, and then the output of the NAND gate may go to another NAND gate. I think it's the OR, I don't remember which one it was that I was working on earlier, but you have a NAND gate, and then you have another NAND gate, and then you have the output of these two NAND gates going to another one. So you basically are just going to draw lines. So what I'm going to do is to show you, let's see, suppose that you want the output of this one to go to both of these inputs. And remember that the symbol, or in drawing these things, if you had a NAND here and you needed the same input to go to both of these, it was drawn like this. So we need one thing here to go to both of those. So suppose that I want the output of this one to go over to the input of this one. Now I could have it here, but I'm going to make it go over there. So I would draw a line from here, kind of around here, in between here, and out here. And then I would probably stop there, and then draw a line to there, and then a line to there. So that's how you would, on your paper, indicate that the output of this went to both of these inputs. And then, of course, the output of this, well, if you have this green, then you wouldn't have this one here, and so then this would be to logic indicator 1. Okay, make that into a 1. Okay. So kind of the red things here, you would still probably need, maybe I'll do it this way, S1 and S2. Okay, so the reds go together, S1 and S2 as input, and we have this output to logic indicator 1. Now if we put both of these S1 and S2 into here and took this output and went over to here and put it into these two places for this input and got an output here to logic indicator 1, the green goes together and the red goes together. And as I said, in all of these things that we're going to do, we are only going to have one output. So you can use logic indicator 1, 2, 3. I don't care which one you use. And then you're going to do the switches to either zeros or ones. Zeros down, 1 would be up, and then you'll end up seeing whether your LED corresponds to what your output is. So the 0 output should correspond to a green LED, and a 1 output should correspond to a red LED. Now, I haven't quite got this written and organized yet, ready to post, but my plan is that since there are 4 of these on a page, and there were 5 gates, I was going to have you to do each of the 5 gates, so 4 on one page, and then 1 on another page, and then the other 3, I'm going to draw some combination of NAND gates. Now obviously I can't have any more than 4. I mean, I could, but because I sent you 2 chips, but I won't. So I'll have 4 gates at the most. And I will have some combination that doesn't represent anything in particular, but it's just something that I'm going to make up. So I'm going to make up 3 of them for the second page. Now, I suppose if you wanted to, you could go through and do the logic and fill out a truth table. What I will need to do, though, for the 3 that you're going to do, is I will have a truth table somewhere, probably on the next page. I haven't decided exactly how I want to organize this yet. But I will have a truth table so that you can see and show the outputs, the output for each of the combinations of the inputs. And I quite likely am going to have at least one of these that has 2 NAND gates for inputs, so that you have a switch 1 and 2 and 3 and 4. So I haven't drawn those yet, so I'm not sure exactly what I'm going to have. But the idea will be that whatever I have, that you will end up, after you get it connected, that you will draw the connections on your diagram here, and then for the three that I make up, I will have a truth table, probably on the next page, for you to fill out. So the basic idea for this lesson is to get some practice at connecting these things and using this chip. So now I want to go to the circuit, and let's see, I think I've said up here at the board all I need to say. Yeah. Okay, let's go over here to the circuit. Get my pointer. And I already have some things connected. So what you will notice, let me kind of move this apart. I have the chip here. Notice it straddles one of these. I would recommend that you put it either here or here. Notice I have wires down to the switches and wires up here to this upper right hand corner. So probably the first thing you should do is pin 7, okay, which is the bottom pin, goes to ground. So I have it going to this ground up here. Now it's also possible, if it's more convenient, to use the ground in the lower left hand corner, because both grounds are the same. If you use the one over here, be sure that you use the lower rows that match the outside of this. If you use these upper rows, it goes to the inside, which is not a ground. Okay, so I would first ground this, so pin 7 goes up here to ground, and then pin 14, which is up here at the top right, goes up here to the red fixed 5 volt terminal. So that's the first thing you do. And basically, once you get those two there, then you don't really need to move those. Now, I have this set for what I have on the board in red. So, if we're going to use the first NAND gate, now obviously it doesn't matter, if you're going to use one, it doesn't matter which of the 4 that you use. But in the book, he was describing using the top left one. So, pins 1, 2, and 3 are the ones that go to the first NAND gate. And then he says, and you have to ground the other inputs. So that's why I have all these wires here. Now, there are several ways you can do this. However, I would not recommend going from all 6 pins, because it's 4, 5, 9, 10, 12, and 13. I would not recommend having a wire going from each of those up here to this upper right hand corner, or you're going to have 7 wires going into this ground, and that's probably not the best thing to do. So what I have done is I've used the wires, and you can call them jumper wires. They go from one spot to another spot. So after I grounded this, then I have another wire, and I've used red ones and black ones. It doesn't matter what color, and I'm not consistent about black for ground and red for anything else. I just use whatever wires I had. So I went also from 7, pin 7, which is grounded, over here to another region. And then I've gone from this pin up to, let's see, what did I do? Oh, 2 of these. Okay, these 2. Yeah, these 2. So I've gone from 4 and 5 over here, down here to this one, which is ground. And I've gone from 10 and 11, which are kind of in here, to this row. And then, since this only has 5, I decided that since ground is ground, I went from in 12 and 13, which are these two up here, down to 8, 9, 10, down to pin 10. So since 10 goes to down here, which goes over to here, which goes up here to ground, then those pins are grounded. So be sure that you ground the input, not the output. And you have to remember that, or just keep track of which pins are the ones that are input and which are output. So you should keep your diagram handy. Okay, so I've grounded the inputs for the 3 NAND gates that I'm not going to use. And then we'll go over here. I'll kind of scrunch these down so you can see. So I've gone now from the switch, and leave these other things, the other switches where they were for the other lesson. This one's on +5. This one, logic indicator, is at +5 and CMOS. So if you just leave them where they were. So I've gone from switch 1 over here to pin number 1. And I've gone from switch 2 to pin number 2. Now you can do it the other way, but it just seems easier to keep 1 with 1 and 2 with 2. And then pin 3 is the output, so I've got it going over here to logic indicator 1. Now this is the one, you can put it in any one of these if you want to, but I just decided to use 1. Now you notice that the red light is on, so this is a 1, but let's see why that's a 1. Over here for switch 1, I've got this down, which is 0. Switch 2 is down, which is 0. So these are the 2 inputs. This is the A and the B. And if you look back at your NAND gate truth table, for the first row, when you have 0 and 0, the output is a 1. So when we have this is 0, this is 0, we should get 1, which is the high, and it even says here, high and low. So our red LED is on. Now, if I switch, or change, let me do it that way. I'm going to change switch 1, actually switch 2, because in the second row I did that as 0 and 1. So I leave switch 1 down for 0, switch 2 up for 1. So 0 and 1 on your truth table comes out to be a 1, and you see that this is still red, which is high. Then the third row is a 1, which means this is up, and the second one is down. So this is a 1 and a 0, and notice that I still have a 1, which is high. Then if I put switch 2 up so that I have a 1 and a 1, then the fourth row, 1 and 1 for a NAND is a 0, so that's the low, so we have this changing to green. So this verifies the truth table. So the plan then is for you to do the other 4, well actually there's 5. This is just looking at the NAND gate, at one NAND gate. So the plan is for you to do the 5 other gates based on what you had in lesson 21 as far as the diagrams, and to verify those truth tables. Now I can tell you ahead of time, you're going to have lots of wires here, and they're going to be going from on the left side over to the right side. Sometimes you will have to go out to some place to make more connections. The main thing is make sure that you've got the wires in the proper row. Those pins are close together, and sometimes it's kind of difficult to see which row things are in, but you just need to be kind of careful there. And I have worked through all of the ones except the exclusive OR, and they all work very nicely, so I expect that one to work nicely. And then, as I said, I'm going to have 3 of them where I have just made up various combinations of NAND gates, and I'll have a truth table for you to fill out for those. So I guess if you have questions, you can call me. And as far as I know, this will be the last video, so I guess I hope you've had some fun and learned something maybe along the way. I will also be posting things about the final and I don't know, some other comments or whatever. So anyway, I hope this works out well for you.